Hello everyone, welcome to this session on vector calculus. Vector calculus can be broadly classified as vector differentiation and vector integration. But for any operation, we will be needing an vector operator. What is meant by operator? An operator is something that takes in an input and generates an output. That is something like our mathematical operators like plus, minus, multiplication and division and so on. So what all these operators do, they take in two numbers or some elements, operate on them, and then they provide us an output. In the same way, when we want to do operations on vectors, then we use this special operator called as vector differential operator. Now let us define what is meant by it and how to use it, or where can we use this vector differential operator. Vector differential operator is denoted by the symbol inverted delta. We call it as delta, which is equivalent to I vector dou by dou x plus j vector dou by dou y plus k vector dou by dou z. So we write an equivalent to sign because it can take an input. Only after taking in an input it has a value. Before that it is just like an element that doesn't hold any value or any magnitude or quantity to it. So it takes in an input. So what is going to be an input in case of a vector? In case of a vector, you can have a vector as an input or a scalar as an input. Normally when you write a scalar is a quantity that has just magnitude alone. So you can define it like a simple element called as f. But when it comes to a vector, it is a quantity that has both a magnitude as well as a direction. So to denote the direction, we use an arrow on top of it. So if you are finding an arrow on top of any element or a script, then that denotes a vector. So it has a magnitude as well as a direction. If it doesn't have an arrow on top, it is a scalar. So it possesses just magnitude alone and not direction. So this del can take an input of either a scalar, or it can take an input of a vector and then produce an output. So the output which we get out of it can be of three types. So what are the three types which this del can be used to produce? It gives us a quantity called as gradient when this del operates on a scalar. So when this operates on a scalar called as f, this del will take this f as an input and it produces del f. When it comes to a vector, we know that the operation on vector can be of two types. One is going to be called as the dot product. The other one is called as your cross product. When you take the dot product with f vector, you call it by the name divergence. So when this del takes input with a dot product, this f vector is referred as divergence. And when it takes a cross product with this f vector, you denote it by the name curl. So what do these three quantities, gradient, divergence and curl, actually measure? This gradient measures the rate and direction of change which is produced in a scalar field. So this is going to be the scalar on which this del acts. It measures the rate and the direction of change produced in this scalar. What is this del dot f, which is the divergence measure? It measures the magnitude of a source or a sink of a given points in a vector field. So source is something like a point from which your forces emanate. Okay, say suppose this is going to be a quantity where you have water gushing out of it. Okay, so you call this to be points, the vector points over here. It measures the amount of water that gushes out. So you call this point as source. In the same way, you can also measure how much of point or water enters into a point. So this kind of quantity where all the vectors dump into is called as a sink. So the measures or the magnitude of amount of fluid that flows out is called as source, and that flows in is called as sink. You can measure this amount or magnitude of the fluid that flows in or flows out at a point by the quantity called as divergence. The next one is your curl. What does curl measure? It measures the tendency of a vector field to rotate about a point. So how much it can rotate about a point is going to be measured by your cross product, which is denoted as curl. So you have three operations which can be performed by this del, which is going to be referred as gradients, divergence and curl. Gradient acts on a scalar, divergence and vector acts on a vector. Del dot product means divergence, cross product means it is going to be referred as curl. Now we will quickly try applying these three quantities to a problem. Okay, so let me take a scalar. So let my scalar be f is equal to x square yz plus 4xz square. Let me measure what is going to be the gradient of the scalar f. How do you define it as? You define it by the name grad f, and this is nothing but our del f. So what is del f? Del operates on f. Del I know is going to be I dou by dou x. So now this f is an input, so it will become dou f by dou x. J dou by dou y. Now this f becomes input, so it becomes dou f by dou y. K dou by dou z. Now this f becomes an input, so it becomes dou f by dou z. So once the input is taken, the identity will now change as equal to sign. So now you will be having equal to as your operator. Okay, now let me take it as I dou by dou x of, what is my f? X square yz plus 4x z square plus j dou by dou y of, what is my f? X square yz plus 4x z square plus k dou by dou z of x square yz plus 4x z square. Now this is going to be a partial differential operator with respect to which variable? X. So what will happen to the remaining variables? It will have to be treated as constant. So yz is kept as constant. X square on differentiation gives you 2x. Okay, plus the second term 4 is a constant, z square is a constant, x on differentiation gives you 1. So this is the quantity with respect to I. What is the next one? With respect to j. You have to differentiate partially with respect to which variable? Y. So what is the role of x and z? They are going to be constant. So x square z is kept as constant, y on differentiation is going to be equal to 1. And next comes your 4x z square, but this is entirely a constant, you don't find a y. What is constant on differentiation with respect to y? This will become 0. And the last term with respect to which variable now we are going to differentiate? With respect to z. What is the role of x and y? X and y are constant. So x square y is kept as a constant. Z on differentiation is 1 plus 4x is kept as a constant. What is z square on differentiation? So this gives me 2z. So this is going to be called as gradient of the scalar f. Now let us try to apply the same on a vector. So let me take a vector. F vector is equal to x y square I plus 2x square y z j minus 3y z square k. Now I dou by dou x plus j dou by dou y plus k dou by dou z. When I take the dot product with my f vector, which is going to be f1i plus f2j plus f3k, I need to keep the rule in mind. So when this is going to take my dot product and operate, so what will be my del dot f vector? The rule is I dot product with I equal to 1, j dot product with j equal to 1 and k dot product with k equal to 1. All the other mismatch combinations will give me value as 0. That is I dot j will be 0, j dot k will be equal to 0, k dot I will be equal to 0. So all the mismatch combinations will vanish. Only the I dot I, j dot j, k dot k component will remain. Now what will happen when I take the dot product? This alone will remain, this alone will remain, and this alone will remain. So I can just simplify and write this as I dot I is 1. So it is dou by dou x of my f1 plus j dou by dou y of j dot j is 1 dou f2 plus k dot k is 1 dou by dou z of my f3. What is my f1? This is my f1. Okay, this is my f1, this is my f2, this is my f3. Now substitute it over here. Dou by dou x of x y square plus dou by dou y of 2x square y z plus dou by dou z of minus 3y z square. So what happens now? Differentiate with respect to x, you will have y square. Differentiate with respect to y, 2x square z plus differentiate with respect to z, you will have minus 3y z square on differentiation is 2z. So y square plus 2x square z minus 3 2s are 6 y z is going to be the divergence of my f vector. And now comes the last part, which is going to be my curl. How to find the curl of a vector? So let my f vector be equal to x square yi plus y square zj plus z square xk. Now how to find the cross product? Del cross f. So it is the determinant of I dou by dou x and my first component. What is my I component? X square y. J dou by dou y of my second component y square z. K dou by dou z of the third component z square x. So now we will have to find the 3 cross 3 determinant. So it is I, close your vertical row and your vertical column. So what will happen? Cross multiply these two quantities. So I will have this as dou by dou y of z square x minus dou by dou z of y square z. Now the second component will become minus j times of. Now how to find your j component? Hide this row, hide this column. So what you will be left out is the cross multiplication of these two quantity, dou by dou x of z square x minus dou by dou z of x square y. The third and the last component, k times of. How to go about it? So hide your row and hide your column for the last component, cross multiply the remaining two. So in which case you will be left out with dou by dou x of y square z minus dou by dou y of x square y. Now it is a simple differentiation, partial differentiation. So what you will have, I will write it over here so that it will be easy for us to conclude. With respect to y, no y, so this will become 0. With respect to z, you will have minus y square and z is going to be 1. Second term, minus j times of, with respect to x, what you will have? Z square, and with respect to z, no z over here, plus k times of, with respect to x, no x, minus with respect to y, you will have x square. So my final answer will be minus y square I minus z square j minus x square k. So that will be the curl of the vector. So using del, we have found out what is going to be gradient, divergence and curl of a given scalar and vector.